Alright, so the next few videos, maybe 2 or 3 videos, are going to be all focused on EDA, or Exploratory Data Analysis. Exploratory Data Analysis. And this is a crucial step when you are analyzing data, because you don't want to try and throw predictive models on anything until you know what you're dealing with and kind of what patterns that you can find. And really, it's just to understand the independent variables and how they relate to each other before you head down another path of analysis. And so this is it's gonna, like it says here, we're gonna understand the variables, the single variables, and kind of their relationships with each other. We're gonna find some patterns in the data, and what we find here may suggest some modeling strategies depending on the relationships that each of the variables have with one another and with the dependent variable, which is whether or not they purchased a bike in this example. So let's get ready and let's just jump into it. So I'm going to be using a dataset called bikebuyers.csv. I'll try and include the dataset in the description of the video. And we're just going to go ahead and save it in the bike buyers variable name. So if we look up here, just a quick check, in our environment tab, we see that we successfully read in the data, 1,000 observations of 13 variables. Looking good. So these are 3 functions that I like to run whenever I'm doing really any data analysis to begin with. First one's structure, summary, and class. And these are going to give you some really good information just on knowing what your data is all about at a very high level. So if we use structure first, so it tells us it's a data frame, 1,000 observations, 13 variables, very useful information. You can see how big it is. For example, you want to know this because if it's a massive data set, if there's a few 100,000 rows or 1,000,000+ rows, you'll want to break that down. You'll want to just take a sample so that you can run a lot of these calculations quicker. What I mean by calculations is just some of the things that you do the data analysis on. Because if you keep it as the giant data set, it's going to take a while, and it's just going to slow you down. So that's one reason why that is important, to know how many observations there are. You can affect your compute time if you take a sample. So if we look through here, we have ID, marital status, gender, income, children, education, occupation. Really good information here. And as we look at the data types, we want to ask ourselves whether or not we really need to change any of these. And part of that knowledge, part of answering that question, will come through the analysis that we'll be doing. As of right now, it looks pretty good. It looks like the big thing to look out for is that strings, maybe like first names, we got to make sure that those are not converted into factors. And if that were the case, we would just come here and strings is factors equals false. But that's not the case. Everything looks good for right now. We may change some things later. So let's go ahead and look at summary. Alright, so right off the bat we can see all of these variables and kind of some characteristics of them. ID, this is the first thing that kind of catches my eye that we might need to change. It's giving us a spread of these IDs, but you have to ask yourself, do you really want ID in this data set? Sometimes you may want ID in the data set if there's multiple transactions and a customer has a certain ID and the customer's in there multiple times. That would be a good column to keep. But in this data set, let's just view it real quick. It doesn't look like these IDs have any meaning in the data right now. And so that's just going to kind of clutter up our analysis, not by much, but you know, it might do a little bit. So we'll want to drop that. So next we look at marital status. We can immediately see there's more married observations in this data set. This doesn't mean everybody purchased a bike. Just a little reminder, this is the dependent variable in this data set, whether or not they purchased a bike. So right off the bat, more married people, more males than females, not by much. Same with the marital status. We can see the spread of the income. It's way out there, 10,000 to 170,000. You can see the spread of the children, which this one, may bring up some concerns, because if you look at the mean of the number of children, the average, you can't really have 1.9 children, so we may need to change that later. If we look at education, this is saved as a factor, I believe. Yeah, education right here, 5 levels of a factor. So this is a really helpful variable. We got the factors, which, as we remember, are those categories. They're the buckets. And so we see that it's really broken down, and we can see that there are the most number of bachelors. So then we can kind of go through these and just look at what's happening here and what the data contains. North America is the most heavily used region. Alright, so that's some good information. You can continue looking at that if you'd like, just to learn more about it. Another helpful function is class. This one's very simple. It's just going to tell us it's a data frame. We already know that, but sometimes it's just helpful to remember that. And then view and head, we already kind of viewed the data. You can kind of see what values are in here. And then the head gives you the top 6. So we can see pretty much just like the view, but a little bit more of a limited view. So the first thing that we're going to do is take care of the ID column that we talked about right here. We don't want that column, so we're going to include the Dippler library. We're going to use that select function, and we're going to give it the minus sign and ID. And this is going to drop the ID column, and we're going to overwrite whatever we return here. We're going to overwrite bike buyers, which is the original name of the data set here. So let's drop that column. Let's look at summary, make sure it worked, and it looks like ID is no longer part of the data set. And something else we can do, we can come up here to view, we can look at it just to double check, and it is gone for sure. So that's what we want. So now that we kind of know a little bit about the data set, and looking at these columns, these variables, and we know it's in here, there's going to be 2 approaches that we're going to take to analyze this data to get to know it better, just to describe the data. We're not trying to answer many questions of why is this happening or why is that happening. We are just trying to describe what's going on, and like we said, possibly find trends in the current data. And the first thing that you want to kind of do is examine the univariate data. So univariate data is pretty simple, just like the name implies. It's samples of one variable. So uni meaning one, and then variate meaning variable, so one variable. So that means we're going to analyze a column at a time if we're interested in the spread of income, for example, or education, whatever it might be. And so like we said, we're not concerned about why, we're just trying to describe the data here. So when it comes to these variables, there's 2 basic types of variables that we come across. And the 2 variables are discrete variables and continuous variables. Now what's the difference between those? It's really simple. A discrete variable, a good example in this data set is education. When it says it's discrete, it means the value has to be within one of these categories. You can think of it like a category. And continuous, a good example on this data set is income. It doesn't have to be a specific number. It's not categorized. It can be as high or as low as it needs to be. With income, it's probably not going to be 0, but this is still considered a continuous variable since it can pretty much continually go up a certain scale, whereas discrete, you have bachelor's to partial high school. Like it will fall somewhere in between there and into one of those categories. So knowing this difference is going to be helpful because when we visualize this data, which is very helpful, R is going to want to behave differently depending on if it's a discrete variable or a continuous variable. So let's jump in and with the EDA process. In the EDA process, the two things that you're really looking for, it's very basic and R handles it very well. We're looking for central tendency and spread. And central tendency is, what are some common values? And what's the most common value? What is the data centered around? And the spread, meaning how varied are the data points? What are the lows? What are the highs? And so you can see some of these right here with the summary, and this is helpful. But if you're communicating this to somebody else, it's helpful to visualize it. So we're going to be using some basic graphs to do that, and it just kind of helps you as well as the data analyzer to better understand your data when you visualize it, because you can actually see it. Humans are very visual creatures, and so we like these pictures. So we're going to be using a box plot, histogram, density plot, pie graph, just some good stuff. So let's go ahead and jump in. First, let's look at not education, but income. So the first thing we need to ask ourselves, is this discrete or continuous? Like we said in the example before, income is a good example of continuous because it is on a continuous scale. So let's first look at central tendency. And if you want to, before we were just using bike buyers, we're looking at the whole thing. If you want to narrow down what you're looking at, then just use the $sign and it'll give you access to the columns. And you can either select with your mouse here, or you can type income. Or even better, you can start to type, and then it highlights it, and you can press tab, and it finishes it for you. It's the lazy man's programming. So let's go ahead and run that. It brings back the spread, the central tendency of the data. We can see that this is the average right here. The mean is 56,000. The median is 60,000. So right away we know it's kind of skewed. Let's go ahead and look at a box plot. Alright, so this box plot is really helpful. And if you're not very familiar with box plots, an easy way to understand it is if we, let's pull this here. If we look here at this basic graph, this is a normal distribution curve, right? And basically a box plot is if you were to take an aerial snapshot, a bird's eye view, looking down on this graph. This is a normal distribution, and like I said, right away we know that this data set is skewed, partly because we see that the mean and the median are different right here. But also if you look right over here, this line right here is the median. And so this is the middle of the data. And we can see that it has a long tail going up and a shorter tail going down towards the lower values. So this is helpful. We know that there's 3 outliers. These are not common values. What these lines indicate right here is that this is the how many standard deviations away from the median. And so these are beyond that normalcy range. So let's go ahead and look at the spread and visualize it kind of like we did, kind of like this graph right here, to get to know what it looks like. So we're going to use HIST, standing for histogram. I forgot to mention this is box plot. Again, if you're curious about any of these, just use a question mark, box plot, and it'll bring up the documentation for it with some examples down at the bottom. So let's use histogram. Right away we see some good information. We see the spread. Remember how we saw with the box plot that there's the long tail right here? Well, if we look at this histogram, you can see that this long tail is right here. And so that kind of gives you a good picture in your mind of what the box plot is showing and what the histogram is showing. So another way that you can do this is you can just call plot. And plot is a basic function in R, and it'll do its best to guess what you're looking for, to guess what kind of graph you're looking for. So we're going to use this, we're going to use plot, the function plot, and within plot we're going to call the function density. And this is going to give us kind of a different type of histogram. It has less bars and more of a smoothed curve. So let's go ahead and run that. Alright, so right here, the density meaning like how many people, how frequently does this occur? So we see that there's two big spikes right here, and that's pretty revealing. Seems like this 50,000 mark, it's either people are right below it or right above it in this data set. So no surprise if you haven't noticed, I use this main parameter for plot, and that sets this graph title, and that's always helpful when you're trying to remember what you're doing. Just to show you my favorite graph, changes it right up here. Let's go ahead and change that back because it makes more sense. Income density spread. Alright. So another interesting thing, you can kind of see a little bump right here, and you kind of just wonder, who are these people up here? What are they doing there? If you want to know more about density, again, question mark density, and it'll tell you more about it. Computes the kernel density. Its default method does so when given the kernel, bandwidth, univariate. So this is a lot of fancy language. I usually find that these arguments or these parameters explain a lot of it. And you can Google it, and people will usually put it in a little bit more of a English or layman terms. So, alright, so next let's look at education. Now that we know a little bit about income, we know this spread. Let's see, I think this is a function that we can do as well. Let's do bike buyers with this mode function. Let's see what it returns. Oh, most common. Nope. Alright, that's not the right one. Well, you can use a function to look up the most common value as well. So let's look at education. Let's the same idea as we did up here. Just going to call summary, and this one we're just going to call plot. So education, as we discussed, is categorical. So it's a discrete variable, so it's going to treat it differently. So if we use summary, as you can tell, since it's a discrete variable or categorical, it doesn't give you the spread like this. It doesn't give you the min, the median, or the max, or anything like that. Instead, it gives you counts in the buckets, like saying this is how many are in this bucket. So let's go ahead and look at that. Alright, so bachelor's, visualized like we already knew, is the most common in this data set. Sometimes if the labels don't appear, you just have to increase the size of the graph and they'll appear. It's helpful to see, partial college is next, but partial high school is by far the least. So, that'll be interesting to note later. Alright, so that's just, we know more about the education in this data set. So now let's look at marital status. Once again, this is categorical. It's either, in this data set, if you look, marital status, married or single, married, single. And even if you run it, we're going to do the same thing, summary, call the column marital status. We'll see that there's only two values here. So we know that there's more married than there are single. So we call plot. Pretty self-explanatory. We can see there's over 500 right here, and just in between 400 and 500. So you may not get exact values here, but you get the meaning. Graphs convey meaning, and that's what's really important with graphs and helpful with graphs, so they convey the meaning of the data. So let's use a different type of graph, maybe a pie. Some people aren't fans of pie graphs, and they really only have limited use cases. They're really not the best. But when you're using, kind of two things that add up to 100%, they can be pretty helpful. So let's call pie. We're going to give it the title of married versus single buyers. Well, I guess you could say customers, because not all of these people bought. So let's use pie. And then right away we see error in pie. X values must be positive. Now why is that? Well, let's look at the documentation and see if we can find anything. Draw a pie chart, vector of non-negative numeric quantities. So it doesn't really explain very explicitly. It might somewhere. Like I was saying earlier, pie charts really aren't the best. Well, apparently they say that in the documentation. They're a very bad way of displaying information. The eye is a good judge of linear measures and bad at judging relative areas. So they're saying, we have this, but if there's a better way, you should use it. But let's just look at pi, see how we can use it. So pi, you have to break these into categories. They're already categories, but you have to put it into a table. It'll only accept a table, which is actually a vector. And so if we look at table, cross tabulation, and table creation, it'll basically, here, let's pull out this and just run it down here and see what we get. So it looks the same, but it structures it a little bit differently behind the scenes. It looks the same as like this summary function, but it structures it differently. So now if we run pi, we'll see a pretty simple pie graph, and we'll see that there's more married than there are single. But like the documentation says, you don't really see any values here, so it doesn't convey the meaning as well as plot, because it has some type of scale to put some type of relative meaning behind what it's visualizing in terms of numbers. So the pie graph is helpful, but remember what R says. Pie charts are a very bad way of displaying information, so be careful when you use pie charts. Alright, so now let's look at children. Let's do a summary. So we have here first quartile, third. Now this is kind of an odd variable. Like we noticed in the beginning, when we were just going through all of the variables with the summary function, we looked at this and we decided, mean, you can't really have 1.9 children. So is this really the best way to really analyze the data by having these as numeric variables? So if we try and plot this, it's just kind of a mess. It takes some time to interpret this, and what it's actually saying is like, here's one child, and here are all the observations that have this many children. So it's not very helpful. So you have to ask yourself, is it the right data type? It's probably not. We want more of like a count of like how many people have 0 children, how many people have 1 child, how many people have 2, 3, 4, 5. So if that's the case, then we want it as a factor, right? Because factors are categories. So a simple way to change that to a factor is just to make this look like a variable. So just write it here, bike buyers, then you access the children here. And then you're going to assign it, you're going to overwrite this just by changing the data type to a factor. And so call the factor function, and it says, okay, bike buyers children. So it's almost like you're calling itself on itself. You're saving itself over itself. But in reality, you're changing the structure of the data. So it won't look any different. Like when I come here, when I look at number of children, this won't look any different. But the way R will handle it will change. So if we run that, now we get a summary. Okay, this is maybe a little bit more of what we want. We see that each number of children is broken up into categories. So now let's look at it. So this is a lot more helpful, right? We can look at this and say, okay, 0 children. That's most people in this data set don't have any children, and the least number is 5. This is kind of, not a lot of people have 5 children, so this is maybe something you would expect. So you might be asking yourself questions like, okay, but what about all this data? Like, what about the ones who specifically bought a bike? We want to know about those people. You can filter out, you can kind of create a subset of the data using this Dippler package. We're going to just call it bot. And we're going to use the filter function within the Dippler package. Call it bike buyer. We're sending in the data set bike buyers, and we're going to look for this criteria. Purchase.bike, which is this column right here, equals yes. And notice the double equal sign. This is a comparative function. And if we had a single equal sign, that is saying that we are assigning a variable called purchase bike to the value of yes, and that's not what we want. So we want to do a comparative thing right here. Let's go ahead and run that, the bot, and we're going to plot bot. Let's look at bot real quick. So it has all the data we want in here, all the same columns, but this time all of these are yeses. So that could lead to some pretty interesting analyses. So I'm going to get rid of that and plot bot children. It sounds terrible when you put it that way. So I'll show you right here that you have access, just like with the bike buyers data set. It'll help you autocomplete. Oops. So right here, now we've visualized, if we say here main equals purchased bikes, yes, you can probably come up with a better title, but now it's a little more descriptive. We look at it and we know what it's talking about. So again, 0 children is the most common. The ratios change a little bit. 1 and 2 is a little more evened out, but it kind of a downward trend like we saw in the other one. So here's a mini challenge for you. Figure out what is the most common commute distance, and I want you to visualize it. And then also try and figure out, did more people buy bikes or not buy bikes? And then visualize that as well. So you can go ahead and pause the video right now and try that little mini challenge and see if you can find a good answer. Alright, I'm going to move on now. So here is just the answers to this little mini challenge. Fairly simple. Hopefully we didn't try and overcomplicate it too much, but you can use the summary function, and we're calling the commute distance column on there. Right away, you can see the numbers down here, but my eyes like these graphs. So, alright, so the people who have to travel the least amount of distance bought bikes, and that kind of makes sense. Like, you don't want to buy a bike if you're going to have to drive to work 10 plus miles. Look at this. That should be pretty obvious, right? That's intuitive about this data set. So now let's look at summary, bike buyers, and we're going to look at how many purchased a bike. So we have a simple yes, no down here, and most people didn't buy a bike. So if we plot it, here we have no's and yeses. So very helpful, super straightforward, and it just compares it really easy and really quickly for you. So that is the end of this video for univariate data analysis. Again, that's just an analyzing one variable, and it got us to some good places. We know a little bit more about the data. And you can go ahead and run more of these tests on more of the columns. We didn't look at everything on here. Might be interesting to look at occupation, or the number of cars they own, whatever it might be. So yeah, good luck, and join in for part 2 when we go over multivariate analysis, which is when we're comparing the relationship between variables.